Alright, I'm going to show you what these numbers mean on a speed square, such as this here, made by Empire. It's not on every speed square. This design here has a big hole here, so there are no numbers printed on it. This is a Swanson speed square, and it doesn't feature those numbers. It has other numbers, but not these ones. So in this video, I'm going to show you and explain what these numbers mean, where they come from, and why are they here in the first place. So let's read it a little bit. Common Rafter conversion. Well, these numbers don't just relate to rafters, roof rafters. They work with stairs, or they actually work with any angles that you need to cut, and where the angle is given in terms of rise and run. Okay. Underneath it says inch rise per foot. That per is a symbol for division. It could also be expressed as a fraction. Every fraction is a division, so either which way it's the same thing. So inch rise per foot equals degrees, and there's a small degree dimple there to mean that this is degrees angle. So according to this table, these are all degrees listed somehow. I'll show you what these mean and where they come from. Typically, angles are expressed as a fraction, and they look like this on a blueprint. You might see this symbol, and there are numbers next to it. I don't know. Let's make it 5. Okay, so you might see this on a blueprint, and you might see another number, 512. The assumption here is that this line here, kind of straightish, that this angle is your pitch angle, and this angle is expressed as a fraction, 5 to 12, or ratio, either which way, however you look at it, or 5 per 12. Whatever words you use is the same idea. You're expressing this angle here as a fraction. So, how do fractions relate to angles? They relate by using the tangent function from trigonometry. So from this angle here, your reference angle, 5 is the opposite side in a triangle from this angle, and 12 is adjacent to it. Not from this angle. From this angle, 5 is adjacent and 12 is opposite, so don't get dyslexic here. That reference angle is really important. That's where I started at. So that's opposite and that's adjacent, and tangent function is opposite over adjacent, or opposite divided by adjacent. That's going to give you an angle, and these angles are listed here. It's not rocket science. This has been known to mankind for thousands of years. So why is a tangent function on a speed square? Well, I'm glad you asked. Let me explain that these angles are important because your blueprints show you these numbers that are whole numbers, but these don't help you cut the pieces. On a miter saw or chop saw, there is usually a circular angle guide on it, and you're going to have to select the angle that's appropriate, that produces the cuts that you need appropriate to the pitch you're working with. So, because your miter saw or chop saw doesn't have ratios or fractions on them, you're going to have to set the angle. And 5 to 12, you don't know what angle that is unless you have a scientific calculator handy, or on a smartphone app or whatever, or you can look at a Rafter table like this. And 5 to 12, this is how it reads. You find the number 5, so that's 5 inches of rise over a foot, that's 12 inches, so that's 5 to 12 is going to give you 22.5 degree angle. Let's test that pudding right away with this scientific calculator here. Like I said, it's a tangent function, and I'm going to enter it two ways. It's actually second function tangent. Don't worry about it, it's calculator stuff. So second function tangent. I'm going to enter it as a division first, so I'm going to use brackets for that. 5 divided by 12, close that bracket, equals, there's your 22.5 degree angle. Why it's not 22.5? You know, close enough is close enough. On a miter saw, there are no decimal places for angles. It's just eyeballing, and it's gonna be close enough on setting the angle on a saw. So there, 22.5. Calculator says 22.62 if you want to round it to 2 decimal places, because these are rounded to 2 decimal places. But look at it, everything is 0.75, 0.50, 0.00, 0.50, 0.50. They really didn't want to complicate anybody's life with any other decimal numbers, and there's really no need for the decimal places either, because you can't select decimal degrees on a chop saw accurately. So there's your 22.5 degree angle entered as a fraction. I'm going to enter it now, entered as a division. Now I'm going to enter it as a fraction. Same deal, second function tangent, and I'm going to use that ABC fraction button there. 5 ABC 12 equals, same deal. So you can enter them without the bracket. You get the same numbers. When you get to 12 and 12, 12 inches of rise over 12 inches of run, you get a 45, 45 equilateral triangle here. So 45, 45, 90 triangle. And that is also reflected by the fact that at number 12, where is it? There. 12 equals 45.00 degrees. And there you have it. That's what's exactly printed on the speed square. Now, according to the calculator and the speed square, I'm going to try to draw a 5 to 12 pitch angle here. And if I select 22.5 degrees, which is 15, 16, 17, 18, 19, 20, 21, 22, that's 23, the next line, that's 23, 22, so let's go to 22.5, just like so. And of course that pivot point is there, it has to be tight. 22.5 is thereabouts. So this line here is now 22.5 degrees from this line. So on your miter saw, this is 0 degrees, or usually it's labeled as 0 degrees, and this one here is your 22.5 ish with my eyeballing. So this is 90 here, and this one is, I don't know, I'm not a calculator. Let's go 90 minus 22.5. That's 67.5 degrees here in this corner here. 67.5 there. And of course it works the other way around, this way as well. So that's another 22.5 degree angle there. That's 67.5 there, and that's 90 there. So whether it's roof or stair or anything where you have to lay out angles, the degrees that you need to set the saw, the miter saw's rotating table at, is given in angles here. That's what this is for. Okay, and that's how you use the numbers. I hope that's very straightforward. Thank you very much for watching.